It might sound like an oxymoron to have a black hole jet. If you know black holes eat everything that comes near them, how can it have a jet? That would be a jet of energy and gas and other materials. So I thought I might spend a minute offering an understanding of the anatomy of the vicinity of a black hole. So a couple of things. If you have a black hole and something's going to fall into it, that can happen. But if it's going to fall straight in, it's got to exactly line up with its position in space for it to fall straight in. Most things that are wandering by are not headed straight to the center of the black hole. They're coming off to the side. Well, it'll feel the gravity of the black hole. Its trajectory will be altered. Yes. For it to get to the middle of the black hole, it needs to lose that orbital energy somehow. And thus is the beginnings of what we call an accretion disk. You have a black hole and there's material coming by. The black hole pulls it in and it swirls. And it slowly then feeds the black hole, feeds the monster. As this material slowly loses energy.
They swear they know what they talking about with these fucking black holes. Well, I'm gonna listen to my boy Neil.
Energy, it gets closer and closer and closer to the black hole, then ultimately gets pulled straight in. Well, all of the material that's coming near a black hole participates in this. Big black holes can have big accretion disks. We're the biggest black holes in the known universe, in the centers of galaxies, where they have a mass equivalent to hundreds of thousands or millions of times the mass of the sun. These are singularly large black holes in the universe, in the centers of galaxies. And we're still debating how they get made. Are they there from the beginning in the formation of the galaxy? Did they occur later? What feeds them? Okay. As long as you're feeding a black hole, it's going to have an accretion disk. And that accretion disk will get hotter and hotter and hotter. Why does it get hotter? Because the orbital energy has to go somewhere. So it goes into heating the gas of this spiraling disk. It gets so hot, it radiates not only in the red or the infrared or not only white hot or blue hot, it is so hot, it radiates X-rays. Oh my gosh, that's highly energetic. Okay, now, how does the energy get out? Which way does it go? It's not going to exit through the accretion disk because the accretion disk is in the way. How's it going to get out? Oh, wait a minute. If it's a disk and I'm energy and I want to get out and I can't get out through the disk, I want to get out above and below. So when we look at the anatomy of black holes, we find accretion disks and plumes of energy spewing forth above and below the black hole itself.
These fucking satellite images.
They're jets of matter and energy mixed together. Energy as in photons, very high temperature matter, ejected from the system because it has to get out somehow. There are only two directions left, the North Pole and the South Pole of this accretion disk. So depending on how massive the black hole is, depending how hungry it is, how many stars are getting flayed by the gravitational field of the black hole before they're eaten, all of this combines so that there's a huge range of the intensity of these jets across the universe, galaxy to galaxy. There will always be one that's longer than the others. And just recently in the news, just such an object was reported. More than 100 times the diameter of the Milky Way. Now, of course, it extends as far as you can detect it. At our current detection threshold, it goes 140 times the diameter of the Milky Way. That's out there. So 140 times the diameter of our Milky Way itself is 100,000 light years across. So 140 times that, we're talking way out in intergalactic space. So that currently holds the record. We might one day find one that goes even farther. A feature of this object is that it's coming from the center of a galaxy itself 7 billion light years away. That's halfway to the beginning of time in the age of the universe. And by the way, this galaxy has a name. It's called Porphyrion, one of the giants of Greek mythology. It turns out, as you look farther out into space, closer back to the beginning of time, black holes had much more material to eat back then in the centers of their galaxies than they do today. This is the origin of what we call quasars. Quasars, that's an acronym for quasi-stellar radio source. Quasars. Quasi-stellar because a lot of intense energy is coming from a small spot on the sky. It's almost star-like. So we're not as surprised to find such a luminous extended jet coming from the center of a galaxy that's that far away from us here on Earth. And as time moved on, the black holes ate everything that was near them, and anybody else was at a safe distance, not to be eaten anytime in the near future. So it makes sense that this is an object as far away as it is. By the way, the very first black hole ever discovered, it happened like in my day, like when I was in college. I was working in the X-ray group at the Center for Astrophysics. It was a summer job. I was an undergraduate. And the X-ray group had pioneered small portable X-rays that would be launched into X-ray satellites that would then observe the universe for X-rays. We did the people did the calculations and knew that if you had a black hole and an accretion disk, the disk would get so hot it would emit X-rays. So you train your X-ray telescope in these regions of our galaxy, you create an X-ray catalog. Now, there are other ways you can make X-rays in the universe, but one way you get them for free is in the vicinity of a black hole. So some of the best black hole candidates were first put forth by these satellites, these early X-ray satellites that were tuned to discover black holes in our midst. The point to be made is there's always one that holds the record. And we've got a new one of late that does just that.
All right, Neil deGrasse Tyson on them black holes. We'll see more about that later. Keep looking up in that damn sky, see what's up there.